Hey, good afternoon, everyone, and welcome to the 65th episode of How Do You Know? And we're really hoping that if you're part of
You
our audience,
you have theme
you
music now, Dr. Barth.
I have theme music, and I love that. Now we need to make like one of those cards where you open the cover of the book and the theme music plays.
I don't think we have the license for that, but
Okay.
we can look into it.
Well, they have those cards where you open them up and they play music like Happy Birthday or Happy Anniversary or whatever, or
You
Christmas
know,
music.
up until a few years ago, you couldn't even play the happy birthday song. It
No,
was
you couldn't.
copywritten, and yeah, you couldn't play it. You
You
get
know,
sued.
um, And for all the Grinches out there, they now make a prank card. It looks like a Christmas card. You open it up and it starts to play the music, but it won't shut up. It just keeps playing for
Till
hours
the
until the
battery is
battery runs out.
dead. Oh,
And if you rip open the card to
you can
try to
kill it with
disconnect
fire.
the battery, you unleash about a pound and a half of glitter
Nice.
in your house.
you
I saw that. Somebody sent me that. And I'm like, I am not a Grinch. I am not buying this ring.
you can kill it with fire. I'm pretty sure.
Yes, you could. You could throw it in the fire. Anyway, we're hoping folks are getting your copy of Star Mentor. Think about this. This is over 340 pages of astronomy activities for small telescope and binocular. For those of you who are wondering, what do I do next with my small telescope, with my binocular? This is the perfect book for you. An excellent holiday gift, by the way, an excellent holiday gift. And if you're enjoying your copy, I hope you'll drop us a review on Amazon or other websites. Anyway, let's go ahead and get started because we have a lot to do today. Some breaking news. I always like to put in breaking news, I'm always searching. And I saw a piece today that scientists have now developed a way to take egg whites and turn them into aerogel. If you've ever seen this stuff with aerogel, where it's this amazing material that's almost transparent. It's about the same density as air, but it's a molecular solid. It's like a sponge-like texture. They can now make this out of egg whites, and you're like, "Oh, okay, that's neat, I guess." But they found out that this egg white aerogel, hey, book, this egg white aerogel can be used as a filter. It's such a good filter, it will filter salt out of water with about a 99% efficiency, and it filters microplastics out of water. This is something that an amazing, amazing technology because it's something everybody worries about. Microplastics in the environment, how do we get them out of there? How do we get enough fresh water for people who need it? Without having to use distillation, which takes a lot of heat or electricity or fossil fuels. Well, this ultrafiltration method with aerogels, they take the egg white, they freeze dry it, and then they put it in an anaerobic environment, no oxygen, and they heat it up to 900 Celsius. That's higher than my oven goes by a long stroke, but it's quite interesting.
You don't want an
Phys.org,
oven that hot in your
phys.org.
house.
Sorry?
You don't want an oven that hot in your house.
No,
You won't
probably
have a
not.
house.
No, that would be a bad day. But phys.org has information, an article on that, and I'm sure some of you will have to look at it. And because today's show is about meteorites, I saw this in the science news today. There's a guy in California who says a meteorite burnt my house down. There was a large bolide meteorite over central California, and this guy says, yes, a piece hit my house and burned it to the ground. No. I actually wrote to the fire department where this guy lives, and I said, "Sorry, this isn't possible." Meteorites, by the way, folks, the kind we see for the Taurids, for the Orionids, or the upcoming Leonids. If any of you are going to be out watching the Leonids around the 15th of this month, they burn up between 40 and 75 miles up. They burn up in the very highest level of the atmosphere. And so if there's chunks, they're falling through frigid air for 50 or 60 or 70 miles. They are not going to be anything other than stone cold. when they hit. And of course, if the meteor is big enough to actually be burning when it hits the ground, it's going to do more than burn your house down. It's going to be a bad day.
Yep.
My students often ask me when we're out watching meteors, why can't we hear them? Why are they perfectly silent? And I explained that this is a little chunk of rock burning up 50 or 60 or 70 miles away. So, of course, you can't hear it. And I said, if you can hear the meteorite, it's not going to be a good day. It's going to be a bad day. So let's get on with today's activities. Killer asteroids hiding in a new asteroid belt. 900, I think, open fire starts at 450. Yeah, the famous, that's from book, the famous Bradbury novel, Fahrenheit 451, which is where paper starts to burn. So yeah, 900 centigrade, but no oxygen. That's the key, no oxygen. So we're going to be talking about a new asteroid belt. And of course, new is a relative term because, of course, asteroids are amongst the oldest things in our solar system, 4 to 5 billion year old. If you're holding a meteorite, you've got something that's incredibly old and ancient. But this is an asteroid belt that we've just started to explore. And you might think to yourself, gosh, is it really far away? And actually, no, it's not. To understand this, you have to take a minute and think about this in a geographic term. If this is our model of the Earth, this is a ping pong, by the way, and we see the daylight side and the nighttime side, we realize, oh, if this is the sunlit side, then the sun is very distant somewhere over here. It's shining this way. And when we look out at the night sky, we are essentially looking away from the sun. So think about that. When we look at the night sky, we're looking away from the sun. Well, okay, how about the planet Mercury, which is closer to the sun than us? We can only see it when it is either just before sunrise or just after sunset because it's so close to the sun. Well, the asteroids we're now talking about are inferior asteroids. And if we think about it in terms of planets, we call the inferior planets the one closer to the sun than us. Mercury and Venus are inferior planets. Superior planets are farther away from the sun than us. Mars, Jupiter, Saturn, and the rest of the boys in the band. Well, these inferior asteroids orbit inside the Earth's orbit. Sometimes, however, they cross the Earth's orbit. Those are called Apollo asteroids after the first one discovered. Well, if you think about it, though, an Apollo asteroid which crosses the Earth's orbit, that's not very good because it's going to go around the sun about once a year. And so once a year, its perihelion brings it out and it crosses the Earth's orbit. Not good. Well, how do we track these things down? You hear all the time, we found all the big and dangerous asteroids. We've just started exploring this space. And it turns out that you can only find these during what we call the twilight window. The twilight window is about a 10-minute period after the sun sets and before the sun rises. We're looking just toward the sun, so we're looking at the inferior space, the space closer to the sun than us. But if we wait too long, either the Earth carries us around to where we're looking away from the sun again, that's at night, or in the morning, the Earth's rotation carries us around into full daylight, and then the sky blazes a beautiful blue, and we can no longer see these objects. You have to remember, this isn't like planet Mercury, which is several thousand kilometers wide. These things are on the 1 kilometer class and smaller, so they are very faint indeed. So each day you get 20 minutes of time total, sunrise and sunset, to go search for these objects. It's a very, very challenging activity. The observatory that's going after these things is Cerro Tololo. the Inter-American Observatory, that's in South America. And Cerro Tololo has a new camera called the Dark Energy Camera, or the DE Cam, and it's part of the NOIR Lab program, NOIR, and the Near Earth Asteroid Investigation Research Program. And the NOIR Lab, I love these acronyms these guys make. I mean, I've tried to make these things up. I can't even do it. So they're looking for these asteroids hiding in the sun's glare. The reason they can do this is the DE cam, the dark energy camera, is both very wide field and super sensitive. It's one of the most sensitive cameras to date, because you have to have something very sensitive to pick up these very small asteroids. So what have we discovered? It's a new program. It's a new discovery program. What have we found? Well, according to a report that was released just on October 31st of this year, so just a few days ago, 3 new large near-Earth asteroids have been discovered. So the asteroid named 2022 AP7 is 1.5 kilometers wide. That's a big bad boy. That is not your bolide. That is not your Chelyabinsk Meteor. A asteroid in the 1 to 10 kilometer size class is referred to as a dinosaur killer. Something like this, 1.5 kilometers wide. The dinosaur killer itself, the Chicxulub impact, theorized to be somewhere between 8 and 10 kilometers in diameter. This one, you might say, oh, well, it's 1/7 that size. That's better. No, sorry, it's really not.
If it hits the ocean,
like this,
it's still hitting the Earth.
Yes, if it hits the Earth, this is something that would cause global environmental damage. It would cause significant species extinctions. We might get lucky where most of the damage might be relegated to one hemisphere. Anybody see the movie On the Beach with Gregory Peck? After a nuclear war and everything's dead? Yeah, pick your favorite apocalyptic movie.
Dirty asteroids.
Yes, the 1959 classic, The World, the Flesh, and the Devil, with Harry Belafonte. The I Am Legend movies, all of these apocalyptic films. Well, you might get lucky with a 1 kilometer asteroid because of the way the Earth's atmospheric patterns are, and it might confine the damage to one hemisphere, and humanity as a species might not go extinct. We got really unlucky with Chicxulub because, first of all, it was hella big, as big as 10 kilometers, and it hit closer to the equator. So the stuff punched into beyond the stratosphere. And something this big, the 1.5 kilometer asteroid, would be a 1.5 million megaton impact. Just let that number sink in. 1.5 million megatons. The largest weapon ever produced by humanity is the Tsar Bomba, made by the Soviet Union. Joseph Stalin asked for a 100 megaton weapon because the United States had just detonated something called Ivy Mike.
Yeah.
That was 15 megatons. That was supposed to be 5, but it was a bigger firecracker than we thought.
Did you know?
And you can look that up. There's video of the explosion.
Hey, Dr. Barth.
But the Tsar Bomba, the plane was able they dropped it off out of the plane. It had a parachute. They did this crazy Immelman loop to get away. The plane survived, but a number of the crewmen died of radiation poisoning. The island that they bombed, much of it isn't there anymore. It's much lower in altitude than it used to be. And that was 50 megatons. We're now talking about something that's so much bigger than that, 1.5 million megatons. It's a crazy amount of damage. Um, the other two we discovered, which are 2021 LJ4 and 2021 PH27, are safe for now, and they're orbiting completely. Yep, a big boom. Yeah, big boom. Tick, tick, boom, as the song famously says. We're bringing the noise. When you're talking about something that big, doesn't matter where it hits, on land, on sea, because for something like that, the sea, which averages 3 to 4 kilometers deep, that's nothing. That's a brick in a mud puddle. You're talking about, if it hits the ocean, literally peeling back the ocean to where it falls on land. Terrible. PH27 is the closest known asteroid to the sun, and that's really interesting because we can study relativity effects. You may or may not know, we've talked about it on this program, that it was the orbit of the planet Mercury which was absolutely instrumental in proving Einstein's theory of special relativity. And people had noted since the mid 1700s that Mercury's orbit was seriously off. The perihelion of Mercury's orbit would shift a fraction of a degree per century, but it was clearly being altered, and nobody understood why. And for a long time, there was a hunt for another planet called Vulcan. And this is Thomas Levinson's book, The Hunt for Vulcan. This is very readable. Don't need to worry about big words or lots of math. It's really a detective story. Loads of fun. Scientists look for the planet Vulcan for more than a century. And they looked during eclipses because that's how they thought they would detect it. The idea that Vulcan was significantly smaller than Mercury, it was very tiny, it was interior to Mercury's orbit, and somehow gravitationally it was dragging Mercury's perihelion and changing Mercury's orbit. Then Albert Einstein, after his 1905 theory, looked and said, "Welp, no, you don't need a planet Vulcan because relativity explains why Mercury's orbit is shifting." With this very close asteroid, PH27, we'll now be able to study its orbit and again further refine the theory of relativity. And as we've talked about many times on this program before, Karl Popper's idea, science is a cage match, everybody trying to tear down the other fellow's theory. We've been testing Einstein's theory for more than a century, and to date, no one has been able to find a weakness, a flaw, or a correction in Einstein's theory. So this new asteroid will be really fun to look at. And we've got links about this special camera that we're using to find these asteroids and studying these things, the DE cam, or the dark energy camera at Cerro Tololo. And there's a link in the the study guide for the show, or the show notes that are on the Explore Alliance page. One of the fascinating things you can do, there's a lovely page, and I have a link to this in the show notes, it's from Purdue University, and it's called the Impact Earth Impact Effects Calculator. And I have a lovely link to that, and I've got this. I'm going to go ahead and share a screen with you. Screen sharing, there we go, and share it, there it is. Now, what I've done there, and I'm assuming you can see this now on your screen. There you go. Thank you, Paul. We've gone ahead and put this in.
Just gotta catch up.
What would happen if we went ahead and had a 1.5 kilometer wide asteroid strike us? And so this impact effect calculator not only lets you do that, it lets you pick a place on the map to whack. So if your in-laws live in or
My
your ex lives in a
ex-wife's
particular
house,
city,
please.
all my exes live in Texas.
I don't just
That's
yeah. My ex-wife's house, if you don't mind.
there you go. Or you could say, what happens if it hits near my town? Well, this impact effects calculator lets you do that. And you can see here what I've picked is 36 degrees latitude, a negative 94.1. Why is that? Because that puts the asteroid coming down relatively close to me and the Barthland Ranch. And so you can see we've selected here a projectile of about 1.5 kilometers. We've made it made of stone, and we've given it an impact velocity of 45 kilometers per second, striking at a 70-degree angle. And we're hitting sedimentary rock, which is what we have here in the Midwest United States. And let's go ahead and display the effects.
Yeah.
And it goes ahead and it brings up a map. And this is, I'm going to switch to maps with names here. And we can go ahead and scroll out. And there's the towns of Greenland and Elkins and Fayetteville. And we can drag our map. And then we can say, okay, boys and girls, what does the crater look like? And so the transient crater is what happens first. That's a crater that's very V-shaped. It's very deep and it's very narrow. But that kind of a steep-walled crater cannot stand up under Earth-like gravity. And so eventually the sides start caving in and it's like a sinkhole. It expands and you can see the final crater there. And this thing goes from, the town of Prairie Grove out to Goshen and down as far as Winslow. And it reaches up Springdale, which is a large community in our area. That's where Explore Scientific is located. So, Paul, you would have a lovely new view on the edge, on the rim of the final crater. You'd probably be very under Ejecta. Yeah, you might be able to visit later, but unless you were vacationing quite far away, yeah. Let's take a look at the air blast. Oh my gosh, there we go.
Wow.
Well, the air blast effects go up into northern Canada. They go out into the western United States, down through central Mexico. They cover
The
the
darker
Gulf of
blue is
Mexico
like
completely.
destruction, right?
Yeah, well, let's zoom in, and we see the interior area, which covers Fayetteville. It actually goes as far as, that's Fort Smith. It goes out as far as Oklahoma City, and up north as far as Springfield, Missouri. And this is, the air blast is strong enough that steel frame buildings will be blown down and collapse. So steel frame skyscrapers, major buildings, you can think of it, if it can blow down a skyscraper, you can think that everything within this inner two circles here is basically blasted flat. Winds at, you're talking winds of hundreds of miles an hour, hurricane force and greater, just blasting out radially. And that's a bad day.
You
It
might be
reaches here.
protected by some topography. You might be protected by some topography.
You could be. You could be. If you were on the other side of a pretty solid hill, you could
Fort
be.
Smith, it's lower in elevation, and it's got, so it might not get that giant of a hit.
I don't think Fort Smith would be spared. because the river valley, it lies along the Arkansas River. I think the river valley would tend to channel winds and strengthen them rather than block them. And there's not a lot of major hills here. If you were on the opposite side of Mount Magazine, the tallest mountain in Arkansas, you might manage it. If you were in some valleys that ran perpendicular to the way the wind blast was coming, you might be okay. But then again, you might have lots of tons of trees and debris just falling into that valley.
And things would be on fire everywhere.
Let's take a look at the fireball. Let's take a look at the fireball.
I got ahead of you.
Oh,
sorry.
Oh my gosh! Look at the fireball. This the inner circle, everything is hundreds of degrees Celsius and is literally obliterated. But you're looking out the secondary circle here. This is where it's hot enough to ignite clothing on your body. Deciduous trees will catch fire and burn. Exposed plywood surfaces, if you have vinyl siding, that would catch fire and burn. Tar paper shingles, asphalt shingles would catch fire and burn. And this goes out as far as, oh, look, Norman, Oklahoma on the south. It goes to Shreveport, Louisiana. The fireball is setting things on fire in Memphis. And as far north as Jefferson City, to Kansas, Wichita, these are all inside the fireball area. The outer fireball area, where the fireball is visible, this covers most of south central Illinois, most southern Indiana, western Kentucky, Tennessee, parts of Alabama, much of Mississippi, most of Louisiana, and a good portion of almost all of Oklahoma and a good portion of Texas. And it goes up into Nebraska and covers the lower half of Iowa. And not hot enough to maybe start things on fire, but enough to wither crops. Okay, so if you're looking at withering crops, and let's take a look at the ejecta. Yeah, this is where stuff from the crater and the blast effects are falling down and landing on you. And so we look in the inner area here where we see the ejecta thickness is 100 meters. Springdale and the Explore Studios are under 100 meters of rock and rubble. And that goes as far out as Huntsville, Winslow.
It's a great way, but a difficult way to get the day off work.
Yeah. If you go out a little farther, and this is, ejecta is 10 meters, 30 feet. So the ejecta will be deep enough to bury a small home, certainly plenty deep enough to collapse the roofs of buildings that aren't blown apart. And if you're thinking, I'm going to get in a bomb shelter, digging out from under 10 meters of rock and soil, not an easy thing. That goes up as far as Pineville, Eureka Springs, Berryville, Tahlequah, and it covers hundreds of square miles down as far as Ozark. And then if you go out to the the ejecta thickness is greater than 1 meter. Do you think you could put a meter of rock and soil on top of your building and collapse a roof? Think lots of bigger buildings like grocery stores, libraries, auditoriums, gymnasiums. A lot of them couldn't take a meter of soil. A lot of older homes might not be able to sustain that. And that goes out as far as Springfield, Missouri, Tulsa, Oklahoma. On the east, it goes out to Flippin and Bull Shoals, Russellville, and goes down into, golly, it's a big area. And if we go out further here, and the ejecta of 10 centimeters, so about 6 inches, that takes us, that's a huge area. That covers many states. And the ejecta where they're going to be able to see some, you look at the United States, it goes down as far as Houston, as far north as Des Moines, Indianapolis, Springfield. And again, it depends which way the wind's blowing. So this circle
Dr. Barth?
really tells you about if there's no wind.
So
So if there's wind, you might see this stretched in sort of a teardrop shape.
Dr. Barth, there might
Yes,
be
sir.
a good way to test how this map, how accurate it is.
Okay.
We had the Mount St. Helens explosion.
We did.
And that would be a good one to simulate if you could figure out the tonnage, and then you could see how accurate the map is. Yeah, or Mount Pinatubo.
I know Mount St. Helens in Washington State, and my wife, who grew up in Long Beach in Southern California, says she had ash from Mount St. Helens in her.
We had some in Arkansas. It was like, we didn't know what it was, and they were like, "Oh, golly, this is ash." So, I mean, it went with the jet stream, I think, is what it did.
Yes, it did. And this certainly would do that. This map doesn't account for the jet stream or anything else.
Our blast radius with topography and things like that, that might be a good place to compare, just, for giggles.
And let's take a look at seismic shaking. And the entire North American continent. And again, if we go in, the Mercalli 7, difficult to stand landslides. Again, the Mercalli 9, that's building destruction. That's a San Andreas type earthquake. Mercalli 7, you're still going to have building, road damage, railway damage. And then you go out to Mercalli 5. And again, this covers a huge section of the Midwest. And if you go out to the very edge, this is Mercalli 3, where you can actually feel it. And we take a look and we go, wow, this earthquake could be felt throughout the North American continent. This is something big enough. The Earth, measured from space, would actually ring like a bell. So there you go. There's the impact effects calculator. And I'm going to go ahead and let's see if I can find it here and stop my sharing. And this is really, really fascinating. And I encourage you to go and explore. And you can take a look at this and you can say, let's see, do I toggle the camera? Click on the screen sharing. There we go. I'm back. So that's the impact effects calculator. And again, go ahead and download the show notes for this week. And it's just fascinating. I used to have my students, there's another version of the impact effects calculator, and I've got both of them on there. So my alt 4, and then there's some letters there. Are we going to be hit? The scientists indicate that this asteroid, we are safe from this asteroid for at least a century. When we look at these sorts of Earth crossing Apollo-type asteroids, they're eventually going to hit Earth, Venus, or Mercury. It's almost a certainty.
As well as our
since
moon.
They cross, it depends how elliptical the orbit is, right? If the orbit is very elliptical, yes, book says this is a what-if scenario, and you're quite correct. This sort of thing, well, the Chelyabinsk Meteor. Chelyabinsk Meteor struck in February of 2013. If you go to YouTube and you look up Russian meteor, the Russians driver cameras, right? The dash cams are very popular there. So there was lots and lots and lots of video of this meteor and footage of the effects. And people went out and they saw it traveling along, and people are hearing these little bangs as this thing goes across the sky, and they're seeing puffs of debris, and they're hearing slight bangs, and then there are several major concussions, effectively sonic booms that some of them collapsed roofs and walls, blew out a lot of windows, injured thousands of people from flying glass and debris. I don't think anyone was killed. And this thing was in the 40 to 80 meter class. So 40 to 80 meters, this would be a city killer. Very fortunately, the Chelyabinsk Meteor came in at an extremely low angle. It grazed along the top of the Earth's atmosphere, and it exploded about 40 miles up, and the pieces showered the Earth. There was lots of meteorite debris from the Chelyabinsk Meteor. But had this thing come in more vertically and struck Chelyabinsk, where instead of the impact force being spread out through the atmosphere, if it was focused downward on the city, it would have killed thousands. Chelyabinsk is not a huge city. I think it's somewhere in the range of 100,000, but it would have killed many thousands, if not tens of thousands, if it were a more vertical impact. It was a 450 kiloton impact. To give you an idea, the Hiroshima and Nagasaki bombs were on the order of 15 kilotons. This thing was 450 to 500 kilotons. So you're talking many, many times the size of Hiroshima or Nagasaki explosion. And if it would have been directed down, it would have wiped out many thousands of people in the city of Chelyabinsk. The scary part is that a strike like that doesn't look very much different from a nuclear detonation. You would have had a fireball, you would have had a mushroom cloud, there would have been no radiation, small comfort to the people on the ground, but the explosion and the heat pulse would have been tremendous. The shock wave and blast would have been tremendous. And if you'd like to go, oh, what if a 10 meter, 20 meter, 50 meter, 100 meter impactor struck near my city, you can go ahead and use the impact effect calculator and say, gosh, I'd like to know if I'm 10 kilometers, 50 kilometers, 100 kilometers away, what would I experience? And the other version of the impact calculator will tell you how high the winds will be, how loud the sound will be, how damaging the concussion will be, what will the heat pulse be like, how big will the fireball appear compared to the sun, what kind of heat effects will you have. And it's kind of fascinating in a morbid sort of, I want to be a mad scientist and end the world sort of way. If anyone's familiar with the novel Footfall by Larry Niven and Jerry Pournelle, about first encounter with an alien race, and they decide to use asteroids as weapons. Yay! So if you're talking about that sort of impact effects calculator, let's say you were 500 kilometers away from a 1.5 kilometer impactor, 310 miles away, for those of you using the imperial system, the fireball would look 7 times bigger than the sun. So our sun covers half a degree. So this would be 3.5 degree wide object. If you're standing outside, much of your body would experience 2nd degree burns, and standing behind a tree or building would save you from that. But grass and deciduous trees would ignite from the heat pulse. So you would find yourself in the middle of a lot of brush fire. An earthquake from the seismic effects at the impact point would be an 8.7 on the Richter scale, and those radiating out 500 kilometers, you would still experience significant shaking, and that would take about 2 minutes to reach you. The air blast reaches you about 25 minutes later, so everything has had time to burn, and then the air blast reaches you. It's about 1/3 atmosphere. You're thinking, oh, only 5 pounds per inch, or only 300 millimeters of mercury. Well, that's enough to collapse wood frame buildings, blow out windows, and 90% of the trees would either be knocked over or have their leaves stripped away. So an impact like this, even from 500 kilometers away. The other thing these impact calculators do not tell us about is they do not tell us about how much dust and material are injected into the upper atmosphere. What are the climatic effects? Nuclear winter type event, cooling the temperature by perhaps tens of degrees for a number of years. Global famine, crop failure across the entire hemisphere for 3 to 5 years, and climatic and temperature lower than expected, poorer growing seasons for up to a decade or two. So something like this, you can see this would disrupt the environment. Vulnerable species would go extinct. An impactor this size almost certainly would not kill off all of humanity because we're a global species. But certainly some millions would die in the initial impact, and millions more from the global climatic effects. So when people say, oh, why do we have to waste money on the DART mission to see if we can move an asteroid? How silly is that? That's science fiction. No. Just no. And if somebody has the time and you can show them the impact effects calculator, here's what would happen. And you realize the Didymos asteroid we deflected with the DART mission, that was a little less than a kilometer, but it was on the same order of size. It was about an 800-meter asteroid. The Dimorphos asteroid, the parent body, is 3 to 4 kilometers, so substantially bigger than the one we're talking about right here. So, yeah, the DART mission is important. So are the telescopes and things which search for these asteroids and track them down, because we can't use DART if we don't know they're there. And I will tell you, Chelyabinsk, as big as it was a complete surprise. No one saw it coming. No one tracked it. No one knew it was there. No one detected it until it started burning across the Russian sky in Siberia. So something like that could fall right out of the sky and coming in at a high impact angle could take out a city with no warning. So yes, we need to fund research programs like this. You need to reach out if you can to your local legislature, make them aware of these things. If you have the opportunity to share these materials, to talk to these people, it's important that they understand. Most of our politicians, the vast majority of them, are not scientists at all. And I don't know if we have any astronomer legislators in the United States, Europe, or anywhere else. I mean, there might be. I don't know who they are.
You going to run for office, Dr. Barth? Is that what you're saying?
No. If you want to write me in, Barth for Emperor, and I will solve all your little problems. That's a long time joke. I always, when there were elections, I always promoted voting in my classroom, and we had mock elections in my high school and college classrooms. And I would often get asked that same question, Paul. Well, why don't you run for office, Doc? And I said, no Congress for me. Barth for emperor. Write me in. It's emperor or nothing.
All or
and
nothing.
then I will
Is that what
solve
you're
all
saying?
these little problems.
All or nothing?
Yes, a benevolent philosopher, astronomer, dictator. There you go. No, I don't want to run for office. Anyway, let's take a look at some other interesting meteor-related things. An interesting theory came out of the University of Leeds, which is in the UK, and I believe, and they have a brilliant idea. Aha! Perhaps the big Theia impact, which formed the moon. Theia is believed to have been a Mars-sized impactor, half the size of Earth. It collided. If you're familiar with the George Pal film, When Worlds Collide, that hypothesizes a Theia-class impactor that destroys the Earth. This impactor formed the moon. It hit the Earth at a glancing angle. The impact stripped a lot of crust from both Theia and the Earth, mixed them together, and the thinking is that the moon probably formed within months, although some models indicate it might have formed within hours, which to me is just wow. But this was 4.5 million years ago. These folks at the University of Leeds have hypothesized this impact might have jump-started Earth's magnetic field, which is just stunning because the magnetic field is absolutely essential to life on Earth. The magnetic field protects us from the harshest solar radiation. It makes the environment on Earth more pleasant and more survivable. When we have big solar storms, it channels much of the material to the poles, to the magnetic poles. We get these tremendous aurora effects, the aurora borealis and australis. And these are beautiful, but they also, real time, they show us that the magnetosphere is working and saving lives. Not just human lives, but all flora and fauna on Earth could be devastated by radiation from a big solar event like this. But the question is, how do these things start? How do we get a magnetic field? Well, we know we need a rapidly rotating planet, for one. We need a rapidly rotating planet. We need a fluid interior that will conduct electricity. The Earth has a liquid iron nickel layer that conducts electricity. The iron core must be strongly magnetized, and this dynamo effect only works if the magnetic field is well aligned with Earth's geographic poles, and so it's lined up with our rotation. Well, the question is, goodness, how do we do that? We know that once you get it started, it's self-sustaining. The beautiful thing is, once it starts, it's self-containing because the magnetic field from the core induces electric currents in the molten nickel iron layer, and the electric currents in turn generate a planetary size magnetic field. But how do we get this started? And did we have a huge magnetized chunk of the core? And one of the things the lead scientists were interested in is, if the core was magnetized to start with, could that survive an impact? You may know if you have a magnet and you hit it with a hammer, you can demagnetize it. You can scramble the magnetic domains and demagnetize a magnet by hitting it with a hammer. And so Theia would have been a pretty effective hammer. So could a magnetic core have survived that? Well, the people from Leeds turn the question on its head and say, well, maybe that jump-started and magnetized our core and jump-started our magnetic field. So this is some interesting research that's going on, and undoubtedly we'll hear more about that in the future. The last little bit of meteor news we have is, what about interstellar meteors? We know that our asteroids, both superior and inferior, were pretty much formed with our solar system. They're some of the oldest things here, but many of us are probably familiar with Oumuamua. Hope I'm saying that right. It's a Hawaiian name. Sorry, apologies to Hawaiian viewers if I'm mucking that up. But Oumuamua is a cigar-shaped object. That's that thing that was up to 1 kilometer long, but less than 100 meters wide. And it was tumbling like a stick you would throw for a dog as it came through our solar system in 2017. And it exhibited some really odd behavior, including non-gravitational acceleration. This thing was accelerating beyond what you would expect from simple gravity. And so the answer, well, we don't know. You might think, oh, what if it's outgassing? Okay, well, if it was traveling through like a spiraling bullet and it was aligned with its axis, you might think, okay, if it was outgassing on one end, that could cause acceleration. But this thing was tumbling. If you put any kind of a rocket jet on it and it's tumbling, it would not give it any sort of a consistent acceleration. But Oumuamua did have a consistent non-gravitational acceleration. No one has explained it. But its speed and its trajectory, it came from somewhere near the Vega star system. Vega is 26 light years away, and it was probably traveling for some millions of years. We have a link to the Oumuamua, but we also found Comet QI Borsov. Borsov is a Russian amateur astronomer. He discovered this comet, and this was in 2019. This thing was moving 175,000 kilometers per hour. Earth in its orbit, by the way, 30,000 kilometers per hour. This thing was moving ridiculously fast. We don't know where it came from. Its trajectory doesn't indicate any particular star system anywhere within several hundred light years of here. So we don't know where Borisov came from. It was a much more typical comet. It had a coma, it had a tail. It acted like a normal comet that just kept falling through from someplace else. But the other interesting thing, NASA has a Center for Near-Earth Object Study, the CNEOS program. And the CNEOS scientists have been combing through the data from CNEOS, and they found data from a rock which was moving too fast. And then they started looking up more of the NASA data, and they were searching, and sorry, that's classified by the Department of Defense. Yes, are we just starting conspiracy theories right here, perhaps? But in 2022, the DoD released enough data that the scientists were able to complete their study of this 2014 meteor. And they said, wow, this thing was coming through at 175,000 kph. It was absolutely extra, not just extraterrestrial, but extrasolar, came from outside our solar system. Well, part of the interesting effect is that the scientists who study these things, you realize, folks, don't you, that when we have these space programs, they send back data, and scientists comb through this data for years. There are people still combing through Mariner and Pioneer and Venera and Viking and the Voyager probes, data from decades ago, and we're still combing through. Well, the scientists kept going through the CNEOS data, and they came across more stuff. And each time they've come across things which look like they're moving too fast, they run up against the classified stop sign, and the Department of Defense has been saying, you can't look at that yet. And so one wonders why exactly, what the rationale is in the DoD. I will not on this program attempt to second guess military intelligence. that just sounds like a fool's errand. But even if you have a 1 meter wide object, if it's going 216,000 kilometers per hour, that's a hell of a bullet, friends. That's a tremendous impact. So we'll watch for more information from that. You too should go out and search the night sky, and you should go out with your own copy of Star Mentor and your small telescope or binocular and get engaged in the night sky. Go and search. Star Mentor will give you lessons and activities of how to learn the sky, how to find your way around, how to use coordinates, how to steer a telescope, and how to bring some knowledge to the eyepiece. Because when we bring knowledge to the eyepiece, we take a lot more wonder away with us. And we hope you will all continue looking up, and we wish you all clear skies. So thank you, everybody, for joining us for another exciting episode of How Do You Know? And we'll be seeing you next week. We will certainly be taking a break week the Monday after Thanksgiving. I will be enjoying Thanksgiving holiday with friends and relatives, and I will be much too full of turkey, mashed potatoes, and pumpkin pie to write a show over that weekend. So we'll let you know. We're going to be skipping the Monday after Thanksgiving. I'm also planning to be on Global Star Party and coming up soon. And if you're in the Northwest Arkansas area, this week, Tuesday, tomorrow night, I will be appearing at the Sugar Creek Astronomy Club, which is meeting at the Waterway Church in Bentonville, Arkansas. So if you are local to our area, I encourage you to come out to the Sugar Creek Astronomy Club meeting, and I'll be speaking there, and you can meet me in person. If you have a copy of Star Mentor, bring it with you, and I'll be happy to sign your book for you. Leave us a review, keep looking up, and thank you, everybody. Bye-bye now. Yes, thank you. Great Thanksgiving indeed.